Hello and welcome to this video on covalent bonding aimed for students of National 5 Chemistry, though anyone studying basic chemistry may find this useful. I'll be focusing on what we call the 7 diatomic elements. Okay, so what we should know already, we should know that the nucleus of an atom is positively charged. That's going to be really important for this video. You should also be aware that electrons orbit the nucleus in energy levels and they are negatively charged. Now the maximum number of electrons in the outer energy level is 8, unless you're dealing with hydrogen or helium where the outer energy level is the first energy level where there's a maximum of 2. Okay, let's consider 2 atoms of chlorine. Okay, when 2 atoms of chlorine come together, a bonding event, we might call it, happens, which joins those atoms together. And they're now going to join together and wander off, bound together as a molecule. Now let's try and work out why that happens, what's going on. Okay, let's take a single atom of chlorine. Okay. Now let's consider what it's made up of. You've got the nucleus there with 17 protons. That's 17 positive charges. And they are what's holding the electrons in place. Now 17 is quite a big number of protons for an atom that size. So that's a strong force of attraction between the nucleus and those outer electrons. Now I've only drawn the force of attraction on that single outer electron, but of course the nucleus attracts all the outer electrons equally strongly. Okay, now let's see what happens when 2 chlorine atoms bump into each other. Now, see those 2 electrons in the middle there? Those electrons are now, for that moment, in the outer energy level of both atoms. And both those electrons are going to be held strongly by those 2 nucleuses. Similarly, those nucleuses are being held tightly by those 2 electrons because charge and attraction work both ways. And this is what's going to stick these 2 atoms together. That shared pair of electrons in the middle, both held tightly by strong forces of attraction. Notice, by the way, both atoms now have full outer energy levels. They both have 8 electrons in the outer energy level. 2 of them, though, are shared. So this is what we're going to call a single covalent bond. It's made up of a shared pair of electrons. And that shared pair is in the outer energy level of both atoms. The outer energy levels of both atoms are now full, with 8 electrons. So you can't add any more, even if you wanted to. Those atoms are now held together by the attraction between the nucleuses and the shared electrons. That shared pair of electrons, then, is what makes up a covalent bond. Any covalent bond is made of a shared pair of electrons that attracts the 2 nucleuses of the 2 atoms involved. Okay, now let's consider oxygen. Okay, now oxygen has positively charged nucleus, this time with 8 protons. But it's a smaller atom. Okay, so those outer electrons aren't as far away from the nucleus as they were in chlorine. So even though there's only 8 protons, that force of attraction on the outer electrons is still strong. Okay? Now let's see what happens if 2 oxygen atoms bump into each other. There we go. Now notice you've got 2 shared pairs of electrons this time. Okay? You've got 4 electrons and they are in the outer energy level of both atoms. Okay? But in the same way as before, the 2 nucleuses are attracted to both shared pairs of electrons. Again, there's a force of attraction that's going to hold those 2 atoms together. Okay, the only difference this time is you've got two shared pairs of electrons. And that's going to be what we call a double covalent bond. Notice we just call it a bond. It's a bond made of two shared pairs of electrons. Okay, so you've got two shared pairs of electrons in a double covalent bond. As before though, both shared pairs of electrons are in the outer energy levels of both atoms. And once again, both outer energy levels are full with 8 electrons. And this is common when bonds form, that they happen in such a way as to give full outer energy levels. And again, the atoms are held together by the force of attraction on the nucleuses by those shared pairs of electrons. Now, I'd love to give you a cute graphic for a triple covalent bond, but drawing this in 2 dimensions is really pretty hard. Okay, so just take my word on this. As you might expect, a triple covalent bond involves 3 shared pairs of electrons. Okay? An example would be nitrogen. Okay? Now this is hard to represent in 2 dimensions, but if you take your thumb, first finger and second finger on one hand and the same fingers on the other and put them together so that the fingertips are touching, you'll get some idea of what I'm talking about. But again, the atoms are held together by the shared pairs of electrons. Okay, so far we have dealt with elements. Okay? Chlorine, oxygen, nitrogen. Now there are 7 elements that go around as 2-atom molecules like those 3. And there they are there. Hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine and iodine. Okay? Along with the formulas note. Hydrogen is H2 because this wanders around as 2-atom molecules. Chlorine is Cl2 because chlorine exists as 2-atom molecules. Okay, let's have a quick look at their structures. Hydrogen is made of 2 hydrogen atoms joined by a single covalent bond. We represent that as a single line. Okay, or more often just with the symbols. Oxygen, there you are, a double covalent bond as we saw earlier. And we represent it like that. As 2 oxygen symbols, 2 O's, with 2 lines to represent a double covalent bond. Each line represents a shared pair of electrons. Nitrogen, we talked about having a triple covalent bond. That's 3 shared pairs of electrons. We represent it like that, 2 ends with 3 lines between. Okay, now these 4 all work the same way as chlorine did. Because they're all in the same group of the periodic table, they all have 7 electrons in their outer energy level. Okay, so there they go. Fluorine, chlorine, bromine and iodine. Okay, now these are the 7 diatomic elements. Okay, you'll need to know these 7. Now there are a number of ways of remembering them. I've heard people refer to them as the magic 7. Other people make up little word plays. I used to use "Oh, have no fear, I carry beer," but these days I tend to call them the gens and the enes. Okay? Because those 3 all end in gen. Okay? And all those end in ene. And no other element in the periodic table ends in either gen or ene. So if you see the name of an element that ends in gen or ene, you know that it's a diatomic element, and when you write its formula, you should write a little 2 after the symbol to show that it's made of made of molecules made of 2 atoms. Okay, well, thanks for watching. Bye just now.